Hello and welcome to Big Dipper to Southern Cross. I'm Edward Gomez, and me and my fellow presenter Rob Hollow are going to be showing you around the southern sky. I'm British, I live in the UK, but I'm actually in California controlling the telescope that we're going to be observing with over the internet, and the telescope is in South Africa. But more about that a little bit later. Now I'll hand over to Rob to introduce himself.
Hi, I'm Rob Hollow. I'm with CSIRO Astronomy and Space Science, and I'm actually sitting in my office down here in Sydney where morning's just starting. So together with Edward, we're going to host you around some of the wonderful objects in the southern sky. Hopefully you're seeing the video coming through nice and clear, and we also encourage you as we go along with the morning, or the evening, or the night time, or the afternoon, wherever you are in the world following us, feel free to put your questions in on the chat window, and we'll be monitoring that, and we'll do our best to answer your questions. So back to you, Edward.
Okay, so I am now going to take control of this telescope, which has been running in a robotic sort of operation, which is our normal way of operating this telescope. So this is a 1 meter telescope. It's about the same size as a large family car, so a sort of a 7-seater car, and as I said, it's in a place called Sutherland, which is in South Africa, and I've just got to some little bit for it in order for us to be able to use it safely, and then go on with the show. So when we're observing, I will try and point you over to the control interface so that you can see exactly what's going on. So our first target is going to be the jewel box, which is it's a star cluster, and it's an open cluster, so all the stars in it are quite young. Now, I've just got to look up the catalogue reference for it, which is NGC 4755.
So the jewel box cluster's one of my personal favourites, one of the things I really love showing people in a telescope. And it's actually in the constellation of Crucis, or probably better known as the Southern Cross, which is the smallest of the constellations, but it's one of the most noticeable ones, and of course it's on the flag of many countries, including Australia, New Zealand, and some other countries. And you're going to look at this, and the reason it's called a jewel box is when you look at it through telescope with your eyes, you've got some beautiful different coloured stars on this sort of crisp dark black background, so it looks like some lovely jewels just laying on a sort of velvet bed, and it's a stunning little object. It's one of my favourite little open clusters, one I always like to show people through the telescope. So we thought it's a great way to kick off with Big Dipper to Southern Cross by showing you one of the highlights of the Southern Cross.
Yeah, so I'm just having a little bit of difficulty with the telescope, first off, because so I should say that this is an experiment for both Rob and myself in running this type of event, and so anything can happen, so be prepared for things not to go according to the carefully crafted plan.
So while we're waiting for it to come around, if you're online and watching us, we'd love to know where you're from, so just put a quick message in saying where you're observing us from. It'd be nice to see where our viewers are.
So the jewel box cluster was it was an optimistic target for us, because actually it's setting, which means it's not going to be visible. It's only just above the horizon at the moment, but it's one of, as Rob said, it's one of the highlights of the Southern Hemisphere. I think actually in the time that we took to do our introduction, it may have gone below the limits of the telescope.
Okay.
So we're going to instead look at a globular cluster called 47 Tucanae. And if I set up the telescope, I'll hand you over to Rob, who can give you some information about it.
Okay, so again, 47 Tucanae is one of the really iconic southern sky objects. It's one of the two really large, bright globulars that are easily seen through even a modest telescope. We've got 47 Tucanae, and the other one, often known as Omega Centauri, we might try and look at later. So 47 Tucanae is in the constellation of the Toucan, and it's a wonderful packed globular cluster. So I'm not sure what the slew time is going to be, but 47 Tucanae is about 15,000 light years away. One of the best examples of a globular you're ever going to see.
So we've acquired the target, and I'm just about to start an exposure on it. Now, globular clusters are full of old stars, and old stars tend to be red. So to get a really impressive image, I'm going to use a red filter. And I'm going to do a 120-second exposure. Remember, we've got a 1-meter mirror on this telescope. So if you're an amateur astronomer and you've observed this object before, or globular clusters before, you may have used very different exposure times. We've got a really big professional astronomy telescope, so that's why we're using quite different exposure times. So just starting the exposure there. And as soon as we get an image back, I will share it with everybody.
So the other,
while this will all work nicely.
While we're waiting for the exposure to come down, for those of you in the Northern Hemisphere, you probably haven't observed much in the Toucan before, but it's also the home to the Small Magellanic Cloud, which is one of our neighbouring dwarf irregular galaxies. And they literally do look like a cloud. You've got the small and the large Magellanic Clouds. You get a nice dark sky in the southern hemisphere, and you can see them quite clearly. And people often mistake them for small clouds. Of course, they're the closest sort of easily visible neighbouring galaxies, and worthy of many hours exploring with telescopes. So
Rob's very fortunate because he lives in Australia, so he gets to see rather a lot of the small and large Magellanic Clouds, but I've never actually seen them. I've only been to the Southern Hemisphere once, and that was to South Africa to visit the telescope that we're using today. And I don't know, actually, Rob, maybe you can tell us, are the Magellanic Clouds visible, throughout the year from where you're based?
Pretty much sometime in the night, yeah, because they're, depending how far south you are, they're verging on circumpolar, so yeah, you'll be able to see them at some stage during the evening when you're down here normally. Quite wonderful objects. I'm hoping to show you a couple of other things over in the Large Magellanic Cloud later.
Yeah, so the Large Magellanic Cloud and the Small Magellanic Cloud, as Rob said, are galaxies. They're enormous, and they're far bigger than the very small field of view that this telescope has. So if we were to point directly, we wouldn't be able to get the whole thing in one exposure. We'd have to do many separate exposures. And we'd probably use up this 2-hour session, and we'd only get a portion of that way through that. So our observation has been completed. So remember, that was I chose a red filter, and hopefully we're going to get our image back very soon. The CCD is reading out, and if I switch over to sharing my screen, you can see exactly what I'm seeing. So this is our. This is not something that we would normally expose to the general public. So you're very fortunate in having this this view, or very unfortunate if you like to think of it, because it looks incredibly complicated. But this is our engineering control interface. And as you can see, there we go. There's our image of 47 Tuc. Now, if I should be able to load it up a little bit bigger. While we're having a look at that, I'm going to set another exposure going in a blue filter so that we can maybe make a color composite of this. So I'm going to select blue. So you can see there that configure filters was flashing a little bit. And that means that the filter wheels on the telescope are all moving around. And then you can see that this word here has changed to configuring. So this is this is quite an astounding piece of engineering. I'm using a piece of software in a web browser in California, and half the way around the world, a little bit more maybe, there is a telescope that is doing all this and sending back little signals telling me what it's done. So again, I'm going to click. You can see my mouse here, hopefully. There's a start button. I'm going to do another exposure, this time with a blue filter, so that we can see the blue light. Okay, now I've switched over to our inspection screen, and we can see our globular cluster. So if I make this a bit bigger, I'm not sure if that will make it any bigger for you. There we go, yeah. And we can zoom in a little bit. So each one of these dots on this screen is a star. A globular cluster is, it's like a miniature galaxy, and there are many, many of them. I think tens of thousands of them that go around our galaxy, the Milky Way galaxy, and they're in a sort of halo around. So the Milky Way galaxy is like two fried eggs back to back. That's the Patrick Moore description of our galaxy. Imagine two fried eggs back to back. So it's a very thin disk. And globular clusters are arranged in a circle or a sphere around with those two fried eggs at the center, and they're like, as I said, mini galaxies. They can have tens or hundreds of thousands of stars in them, but they usually only have very old stars in them. So each one of these is an old star, and old stars tend to be very red. And now we're looking at a black and white picture here, so you can't see that these stars are anything other than white at the moment. But I'm going to try and download this image so that in a little bit I can maybe make a 3-color composite. Okay, so we've got 24 seconds remaining, 17 seconds remaining, so not long to go on our observation. And then I'll do a third observation, and that'll be a green filter, and then I'll stick them all together and hopefully produce a very nice looking 3-color image. And you can hopefully then see that there are a lot more red stars than blue stars. Because remember, blue stars are young stars. So the CCD is just reading out now. So we've got a little bit of time before we can start the next exposure of this beautiful object.
So while Ed's doing that, it's probably worth pointing out that this is really the way most of the major observatories, or many of the major observatories and new facilities are going, where you have remote observing. You don't need to sort of go all the way to the telescope and stay up all night to observe. You can actually be controlling modern telescopes from pretty well anywhere in the world via the internet. Certainly makes very efficient use of the facilities. It's somewhat less romantic, I guess, than going out to the wonderful observatory sites, but it is very efficient.
So I'm just going to now, we've had our blue filter observation taken, so I'm now going to change and we're going to do a green filter observation. And I've stopped sharing the screen with you, so I will move back to sharing it again. Hopefully you can now see the okay, so we've now successfully moved that filter, and we'll start the observation once again. So the flashing start gives us the indication that it has accepted our command, and we are going with this final piece of the of our 3-color image. Just going to check over the one that we just observed. Download that file for later. So this is again is one of our engineering interfaces for looking at our astronomical data. We can zoom in and have a look, so we get a little view here in our little thumbnail view of the. Can move around. So these are looking at our individual stars. They're a little bit blocky because the image that we're seeing is optimized so that it doesn't take too long to download. But maybe if I move our square over to the edge and just sort of see the edge of our globular cluster, we can see that it's called a globular cluster because it's a lot denser with stars in the very center. And if I zoom back out, you can see that it's a lot denser in the center and a lot more diffuse in the outer regions. So you've got a higher concentration of stars, and it just gets less dense as we come out from the very center. So let's see how our observation is going. Still exposing. And we've got quite a bit of time left there. Okay, only 20 seconds left. So I'm going to come off screen sharing, and I think our next target is going to be Rob, help me out here. What are we going to observe next?
The one I was going to recommend we try, if it hasn't already set, would be the Tarantula Nebula, 30 Doradus. I'm a bit worried it may have already set, but if we don't try now, it's going to be too late. So that's NGC 2070.
Yep.
So,
okay. So
it's
as
not
soon
going
as
to
we
be
get
ideal because it's going to be low in the sky if we could see it at all. But let's see if we can grab it before it goes.
Yep.
So it's a stunning object. It's an emission nebula. It's a giant region of star formation in the Large Magellanic Cloud. So what we're going to be looking at here is about 160,000 light years away, and it's a huge region of star formation. And back in 1987, just near this region was where we had supernova 1987A, which is the only supernova that's been visible to the naked eye since the invention of the telescope. And I actually remember going out and seeing this, so you could see the Large Magellanic Cloud. Normally you can't see individual stars in it, but there, for a short time there was a star in there, and that was a real buzz. And it's been something we've been monitoring ever since, trying to see what's happened after that massive star went supernova. So how are we looking there?
Actually, this is quite a. I have a vested interest in this object for many ways because my also an astronomer, and she she studies supernovae, and 1987A has recently been found to have some cosmic dust. It's ejecta in all the things that flew out when the star exploded. So let's try and snap that. Yeah, I think that one's that one is outside of our outside of our tolerances.
Well, look, I think we now let's go and get another really spectacular thing, another personal favourite. And seeing as I work in a radio astronomy facility, we call it CEN-A, but the optical astronomers call it NGC 5128. And so what we're going to have a look at here is a galaxy, but it's a rather special galaxy. It's colloquial name for some people, they call it the Hamburger Galaxy for reasons that may become apparent. I won't explain more at the moment, but it's in the constellation of Centaurus. So again, it's one of these lovely southern sky objects that the poor unfortunate Northern Hemisphere astronomers don't get to see much. But it's a stunning object, and it's a really interesting one for many reasons. So let's see if we can get that. I want to show you then the image.
That's not going to work, Rob. It's down at 20 degrees above the horizon.
Okay.
So that's just a little bit of a stretch for us.
Okay, so how high can we go? Because we're going to struggle.
It's going to be about an altitude of 30 degrees. So there's a beautiful galaxy, NGC 253, which is a spiral.
So the galaxy we're going to be going to now, 253, it's actually relatively close in galactic terms. So it's in the constellation of Sculptor, and it's a nearby spiral galaxy. and we're going to see it's going to appear almost edge-on, not quite, not perfectly edge-on, but it hopefully we should be able to see all the fine dust details and so on in it. It's so it's about 10 million light years away, so not far at all. And of course, in the Southern Hemisphere, we've got some amazing clusters of galaxies visible, things like in constellation of Fornax and Sculptor and the like. We've got I guess, the closest easily visible galaxies in the Large and Small Magellanic Cloud. In the Northern Hemisphere, the classic galaxy, of course, is the Andromeda Galaxy, which is always stunning. We can see it from down here in Australia, but it's always sort of, when we can see it, it's low in the northern sky, so it's not the sort of the stunning object that you would get, from northern climes. But we've got some fantastic ones here. So let's see, we're on our slew time to that, Ed. Yeah,
so we are a little bit ahead of ourselves. So NGC 253 is rising. So that one we'll be able to observe later on in the session.
Okay, we'll put it on the wish list for later.
Yeah, right. That's right. So I've slewed us to a nebula which is called NGC 6281, and we've acquired that target. And I'm just going to grab a 120-second green exposure of that, and we'll take it from there. NGC 6281. So this is a nebula. It's actually an open cluster with some nebulosity around it. So it's a group of very young stars, and the gas that you'll see around them, hopefully see around them, will be shining because these stars are causing it to glow, because so these stars were probably formed out of that gas cloud relatively recently. And when I say relatively recently, I mean within a few million years. That's recent on astronomical timescales. So I'm just going to check in on how we're doing with that exposure. And I'm going to also see how I can go along with making a nice color image out of the previous observations that we had.
So don't forget, if you're following us online and have any questions, just type them in the chat window and we'll do our best to answer them for you.
It doesn't matter what sort of question they are as well, if it's a general astronomy question or if it's a question about what we're actually doing now. Rob and I are seasoned professionals, so we can handle virtually anything you throw at us, from Royal Baby to Doctor Who to astronomy. Actually, I'm not too sure about the Royal Baby questions. Maybe leave those.
Well, they did name it after one of my colleagues, George, so that's nice.
Okay, so our observation of this nebula is reading out from the CCD. So hopefully in a very short while we will get our first glimpse of what it looks like. Here we go. So if I share my screen with you now.
Okay, let's have a look.
So here we go, and you should see a very nice open cluster right in front of you here. So these are, so Rob, if you maybe talk about that.
Yeah, so you can have a look here.
I was going to start, I'll just quickly start another exposure.
Okay, so what you can
And
see,
you
you
carry
can
on.
see these really bright stars in the that seem bigger than the other stars in the field. Now, the reason that the stars seem bigger there isn't necessarily that the stars are physically bigger. It's basically because they're very bright stars, and so as and they're probably closer than the more distant stars, and so what's happening, you're getting more light on the sensor. And so it actually, in effect, smears out over the sensor. So the stars seem to appear bigger. In fact, all the stars in this image are all so far away that ideally they'd appear as point sources. The other thing you can really see about these stars, and the thing that people always associate with stars, is what looks like the sort of starry shape. So you can see that these stars seem to have little spikes coming out of them. And that's not actually from the star at all. It's due to the optics of the telescope. And as the light enters it, you get these diffraction spikes, as they're called. And they certainly make it really pretty. But they're actually an artifact of the optical system. But they can be quite useful because if you sort of draw two lines along either of the axis, you get precisely where the center of the star should be. So we can use them to help determine the position very accurately of these stars. So again, of course, what we're seeing here, these are taken as a grayscale image. So a single exposure on any of the sort of professional charged couple devices that are used on astronomical sensors don't show you color. So you have to take multiple exposures through different filters and then do a lot of post-processing to get sort of stunning color imagery. Which filter are we using for this one, Ed?
So we're going with so the one that's currently up, this is a green filter. And I'm just doing a red filter, and then finally I'll do a blue filter, and we'd expect these stars to appear brightest in blue.
Right, and that's because they'd be relatively young stars. Open clusters like this, where you can see the stars all seem to be clustered together, they have a common origin. These stars would have formed from giant molecular clouds, would have formed at roughly pretty much the same time. But over time, the gravitational disturbances, tidal influences within the disk of the Milky Way will tend to move the stars around a bit, so that over sort of many millions of years the stars will move relative to each other, so that over time eventually we can no longer identify them as belonging to an open cluster. So it's almost certain that our sun would have formed in a cluster somewhat like this, but now we can't determine any sort of cluster specifically associated with the formation of our sun. And remember, of course, our sun's happily middle-aged. It's about 5 billion years old, whereas these are, you know, of the order of probably tens of millions of years old.
Okay, so we're just reading out from the CCD again. We've completed the observation, and we're going to download this image and hopefully make another beautiful color image when we get it.
So while we're waiting to see that, you can actually see the hints of nebulosity, or the fine sort of gas, even in this first image. Now compare it with the second one, and it's a lot more filled in, if you like. There seems to be more of the gas coming down on where I'm looking, sort of on the bottom right part of the image. And so by taking the images through different filters, we're able to get the contrast at the different wavelengths, and it tells the astronomers all sorts of things about what's there, how much of the stuff is there, and the like. Okay, here we go. While we're doing that, Ed, we've actually just had a question come up on the chat line. Look Up Tonight wants to know, is 120 seconds a typical exposure for a globular cluster? Okay,
so no. This is quite a good way of introducing what we've got here. We've got a very large telescope, so I don't know if Look Up Tonight, you might have a telescope in your own back garden, and you might be used to doing much longer exposures if you're a keen astrophotographer, to get a good looking image. Or you might be used to just looking through an eyepiece, and in which case your exposure time with an eyepiece is actually, I'll click off the screen sharing so that you can see me instead. So if you're looking through an eyepiece, you've got an exposure time of a 50th of a second, because that's how quickly your eyes refresh, effectively, which is like the shutter time on a camera. So if you look through an eyepiece and you've got an amateur telescope in a good dark site, you can see globular clusters. They look like fuzzy blobs, and you won't be able to distinguish all of the stars, but you can still see what what it is. So, oh, hang on a second, something funny's gone on with my screen. So 120 seconds is typical for. I would say it's probably a bit on the long side, but if you've got a 2-meter telescope, you're going to use something much shorter. So one of the, in fact, so I work for, as you can see in the lower third, Las Cumbres Observatory. Currently we've got 11 operating telescopes. 9 of them are 1-meter class, like the one that we're using at the moment, and 2 of them are 2-meter class. And obviously you've got, when I say 2 meters, that's not the length of the telescope, that's the size of the mirror. So we've got an enormous collecting area there. And remember I said that this 1-meter telescope is the size of a large family car, sort of 7-seater. The 2-meter telescopes are the size of double-decker buses. So they're incredibly big beasts, and they take a very much shorter time to take an observation of a globular cluster. And actually, one of our 2-meter telescopes is just down the road in relative terms to Rob, in Coonabarabran.
Yeah, that's right. That's about what, 5-hour drive from here. Up in the northwest, it's sort of up in telescope country, New South Wales. We've got several observatories out that way, including we've got the Parkes Radio Observatory. And then a few hours north, you've got Coonabarabran, which at Siding Spring has the large optical telescopes in Australia, including the Anglo-Australian telescope, the UK Schmidt telescope. It's got the 2.3-meter telescope that ANU runs. It's got the new Sky Mapper telescope that's doing a wonderful Southern Sky star survey, and that's headed up by Nobel laureate Professor Brian Schmidt from ANU. And also up there is the 2-meter, and I think, are you going to have a 1-meter there, or are you having some of the 40-centimeter ones up there, Edward?
Well, we've currently got 2 1-meters at Siding Spring, and we've got plans to put a further 2.4 meters there.
It's a lovely spot.
The exciting thing about the 0.4 meters is that, so as I said, these are telescopes which are used by professionals, the 2 meters and the 1 meters, but the 40-centimeter ones will be able to be used by amateur astronomers, school kids, anybody with an interest in astronomy. And that's something that's very close to both Rob and my hearts, is engaging with the public on in astronomy projects. So really quite excited about the possibilities of those. So I'm going to go back to sharing the screen again, because we've had our final piece of this 3-color image come through. And hopefully you can see, there we go, this is our final one. So I'll just load this up a little bit bigger for us. Here we go, you can see, there we are. And this is our final, so this was, let me remind myself, this was a B filter. So this is a blue filter. So I'm just going to download that image. And make sure I've got the other one, so I can make a nice color image out of that. It's got a crosshairs in front of it, so you don't need to worry about that. Just remove it. So there we go. There's our, so if we can flick between 3 different filtered observations, so what did we do first? We did green first, then red, and then blue. So actually, we've got a lot more stars in this this red image than we have in the green or the blue. Now those are probably background stars that are appearing brighter than they are in the other ones. But these stars, these bright ones, the ones actually in the cluster, not the ones that are either in the foreground or in the background, these ones are the ones that we were saying should be brighter in blue. It's very difficult to tell by just comparing these three things in this way. So I've downloaded the data and I'll make a color composite image. But before we do that, we should get slewing onto our next target. So I've had some suggestions from my QI elf in this office. For some things which could be nice and visible for us. So just going to check one of them out. We seem to have been jinxing them when we. But I guess you can see my screen. So. Okay, I'm going to flick the screen sharing off so that you get to look at something far more beautiful than me looking at the control interface. You get to look at Rob.
Oh dear, poor you. No, that's okay. So we're going to, what's the object we're going to go to now, Ed? Is it NGC 2442?
It's not, no. It's a surprise object which will be very familiar, I think, to many people on the list, which is actually visible in the Northern Hemisphere. It's M16, the Eagle Nebula.
Aha.
So apologies, Rob, for for taking us out of the true Southern Hemisphere. But it's such a beautiful object that I just couldn't resist it.
That's enough too. When you've got a 1 meter telescope to play with, you might as well show the nice stuff.
Yeah, that's right. So I'm just going to check on those. So maybe if you would like to tell everyone a little bit more about the Eagle Nebula.
Yeah, so the Eagle Nebula is what we call, it's an emission nebula, or it's an H2 region. So basically what we're looking at here is, again, a region of star formation. In this case, it's about 7,000 light years away. And many of you would know of this from the stunning sort of what was called the Pillars of Creation Hubble Space Telescope image. So this is quite a bright nebula, and that famous Hubble image was really just showing a very small part of a huge region of nebulosity. So it's quite large. The Hubble Space Telescope looks at a tiny patch of sky. You've got star formation, you've got a cluster in there, hot, bright young stars, and huge amounts of nebulosity. So depending exactly which region we end up looking at, we may end up seeing some of these sort of pillars coming up through. The name the Eagle Nebula actually refers to the fact that when you look at the overall nebula, it looks a bit like the shape of an eagle. So indeed, many astronomical objects are sort of named after the shape they appear to the observer through the eyepiece or through a photo or an image. So let's go and see. Are we on source yet? Great.
Yeah, we're on source and we're taking an exposure.
Yep.
Just checking my source lists.
So the Eagle Nebula is actually in the constellation of Serpens, which again is a southern hemisphere sort of constellation, as you can imagine, named after the serpent. Let's have a look. Okay. Which color, which image, which filter are you going to use first for this one?
So we're going with red. I thought that would probably be the most spectacular.
Should show some great nebulosity.
Yeah, that's right. While we're looking at that, I made a very quick composite image of our 3 color images of the globular cluster 47 Tucanae, and I'll show you that. So I think it may look a little bit squashed on. There you go. So you can see that it's not perfectly lined up. The red, green, and blue images are a little bit squiffy on the alignment. I wrote a script that produces this, and the alignment hasn't worked perfectly, but you can still get a very good sense that you've got a high concentration of stars in the middle, and they mostly appear white. It's very difficult to tell, actually. They look quite green. That's because the blue and the red, green, and the blue don't overlap particularly well. So that gives you an indication. That gives you a good overview of this enormous globular cluster. I've chosen the level so that you can see the extent of it, but actually there's a lot more density of stars in there, which if I chose different levels, you'd be able to see in quite a different way. So we're just reading out the so close that, and there we go. So we're loading our image, so I'll just go back to the screen share. Now hopefully you won't be too disappointed with this one, because I've just seen it and it looks really rather nice.
Wow.
So there we go, there's our image of the Eagle Nebula. It never fails to impress me how beautiful this is. Let's load it up larger. And actually, while we're waiting for that to go, I'm going to change this so that we can. Actually, maybe we'd be better off not doing a color one of this and go and grab some other targets. So I'll just start the tracking. So I think maybe we'll go off to M20. M20 is I think that's the Trifid nebula. I'm going to see if that's visible for us. There we go. So we're off and moving to that, and I'll flick us back to this so that we can have a better look at the Eagle.
So the Trifid Nebula is in Sagittarius. It's another one of these H2 regions. So it's actually a combination. We've got lots of nebulosity emission, again suggesting a lot of relatively young stars. We've got some other region of the nebula where we're getting reflection nebula, and you'll see some sort of dark lanes through it. So it's again one of these stunning sort of images. Stellar nursery, lots going on there. So places like this are a constant source of interest to astronomers because there's so many different things happening in there. There's lots to study. Want to try and view it as many different wave bands as possible. And again, this thing's not too far away. It's of the order of about 5,000 light years from us.
So there we go. We're getting a 90-second exposure of that. I'm going to unshare my screen so I can do some telescope operations type things. Now there is, actually I will show you this while I've still got my screen shared. This is our publicly viewable telescope operations center. You can see the URL there. It's telops.lcogt.net, and this is what we use for a very quick overview of what's going on at the telescope. So this is Sutherland. Remember I said it's in South Africa, so Sutherland. And these are our 3 observatories and 3 1 meters. We're currently using this one here, Dome A, or DOMA, as it says there. So we've got various different bits of information here about that we can check on. We've got an overall status there, which is a warning triangle, but actually isn't that much to be worried about. Then we can see immediately that the warning is here on the site, and that the server is actually unreachable, but that's quite normal because there's a certain amount of latency in the different connections there. That's the least important. That's why it's at the bottom out of all these different things. But we've got nice green spots on all of the other sites. But we can check on anywhere in our network. And so currently in darkness, we have Siding Spring. And at Siding Spring, we have, as I was saying earlier, so that's in New South Wales in Australia, close to Rob, about 5 hours from Rob. And we've got 2 1 meters there. And if I have a look on this one, oh, you can just about see in the corner, if that's a webcam image, just in the corner there, you can see the edge of something glowing in the moonlight. So let's put ourselves back to Sutherland and let's see how we're getting on with this exposure. Okay, so we've done that. There we go. That's a pretty nice image. It's the Tarantula Nebula. Oops.
Trifid, isn't it?
Sorry, the Trifid Nebula. Yeah. Slip of the tongue there. And thank you very much to the QI Elf who suggested that. So that's as Rob was describing, you can see. So if I'm actually going to set going another exposure in a different filter before we have a chat about that. There we go. That's going now. So we've got, it's a little bit off center there, but that's okay because we wouldn't have fitted the whole thing in our field of view anyway. So we've got these dark regions here, if you can see my mouse. Those are cosmic dust, so those aren't holes in the nebula, those are bits of cosmic dust. And you can see there's other dust lanes here as well. And so dust is everywhere in the cosmos. It's actually quite surprising how ubiquitous dust is. Right, let me just get my thinking hat on. So that was a V exposure, and I'm going to start us going. So cosmic dust is everywhere. So we were looking at a red filter observation there, and that's quite good. So what we're seeing here is things that shine red light. And the type of things that shine red light are hydrogen. Hydrogen has very strong emission in red light, and that's to be expected because most of the gas that's in the universe is hydrogen. And we'd expect that actually you'd form stars and all the other things in the universe out of whatever's most abundant. So that's hydrogen. You form stars from hydrogen and little bits and pieces of other things, but the majority of it's hydrogen. And so what we're seeing here is a big lump of hydrogen gas, which glows red. And if we had a special filter called an H-alpha filter, hydrogen alpha, we'd be able to see a very particular color of red, which is a very good indication that we've got hydrogen shining at a very particular wavelength, very particular color. Let's see how our observation is going with that. I'm going to turn off my screen sharing, and I'm going to try and make a nice image that we can put onto the website so that you can all have a look in more detail at the things that we've been observing. So we're just going to...
So while we're just waiting for that, I'm just going to move my webcam and show you why we're not using the Siding Spring telescopes at the moment. So basically because, as you can see there, it's already daytime here in Sydney. So we're not using the ones just up the road from me.
And similarly in California, I will reciprocate, and if I point, so this is my webcam. I'm not sure where our viewers are from, but if you're in the US, continental US, you'll realize that I say continental US, that's a very UK thing to say when you talk about continental Europe. If you're on the mainland of the US, you probably realize that it's light outside, but if you're from elsewhere, you might not realize that California is in daytime, even though it's what we're approaching 2200 UT, which is 3 o'clock, nearly 3 o'clock in the afternoon for me, and ridiculous o'clock for Rob.
Oh no, it's almost 8 o'clock in the morning. That's fine. Yeah.
Oh, easy peasy.
Sunday's well and truly underway. So, but this is, of course, one of the issues with telescopes. When you're dealing with, colleagues around the world and all trying to schedule things and everything, it can get very confusing if you don't make very clear what time you're doing. So, for this reason, we normally talk in what we call UTC, or Universal Time, which is commonly known, I guess, as Greenwich Mean Time. So, when you're scheduling things, you've got to make sure you do things in a common time.
That's right, yeah. So I think so. I've grabbed 2 observations of the Trifid Nebula. They've been so beautiful that I'm inclined to grab a 3rd one so that we can have a nice colour observation. So we did B and V. So I'm going to switch us over to. Sorry, we did R. We did red and blue, didn't we? Yeah, so we've done R, V, and so we're now going to do a blue, so that we can have a nice chunk of a colour image for us. I'm going to try and do it with my my pipeline again, see if that works any better than it did with the globular cluster. So I have a piece of software called FITS Liberator on my computer, and that allows me to. So astronomers, professional astronomers, don't tend to use JPEGs like you get from digital camera. We tend to use a RAW format called FITS, which stands for Flexible Image Transport System, and it was actually developed for medical imaging, I believe, and it allows you to have a file which is an image, but it contains everything, all the data in there. So the images that we've been showing you, although they've been black and white, they actually contain a lot more information in there. Each pixel, each small square of the image, the smallest square that the image can be divided into, has a range of values from 0 to 65,000, and they're effectively brightness values. They're a measure of how much light has fallen on the digital camera, if in effect the CCD that we're using, and so in order to turn that into an image, what I was showing you then was a very quick way of viewing that. We just use some presets. But if we want to have more control over the levels, change the brightness of them, pull out certain features, make it behave exactly the same as RI, because RI isn't the linear thing. We see, because otherwise we wouldn't be able to see the same range. We can see very faint things, we can see very bright things. If you think of when you go out at night, it takes your eyes a while to adapt. So our eyes respond to things non-linearly in a logarithmic way. So we can, but digital cameras don't necessarily. So we can do all those sorts of things. We can play around with images like that. We're not faking them in any way. We're just tweaking them so that we can extract the best amount of detail from them as possible, the most science, if you like. So I'm just going to load in some of my data. Well, actually, let me see how we're doing with this observation. Okay, so it looks like we've done that. So I'm going to download that, and once I've downloaded that, I'll make a 3-color image for us. but I'm going to download the. Well, let's get going on our next target, which let's see if it's time for us to do NGC 253, shall we?
Sounds good.
So we're good to go with that.
Great. Okay.
So that'll be a nice one for us.
Well, this will be our first full galaxy for the session. This is
That's
that
right.
wonderful edge-on spiral galaxy in the constellation of Sculptor, one of our southern constellations. So this should be a lovely image. Now, the interesting thing about this one, this galaxy was actually discovered by Caroline Herschel, who was a really pioneering female astronomer. She was the brother of William Herschel, who again.
I think she was the sister of William Herschel, not the brother.
Hey, I told you it's early in the morning for me here in Australia. Not much sleep. Yes, you know what I mean. Yes, the sister of William Herschel. So it's going to be interesting to see. It was also observed by John Herschel, who was the son of William Herschel, and John Herschel, famous astronomer in his own right, who observed this from using a telescope down in South Africa. So not far from, well, actually he had a telescope at the Cape of Good Hope. And of course, the telescope we're using today is at Sutherland down in the in South Africa too. So how are we going there? Is it?
Yeah, we're on target and we're currently observing. So
wonderful.
Yeah. So I'm going to do a. So what might be nice, Rob, is if you tell the viewers we're halfway in a little bit more about yourself, and I'll just carry on with the observing, and hopefully have, by the time you've done, I'll have a nice colour image for you.
All right. Okay. Well, look. While we're doing that, I'll just say who I am and a little bit about where I work. So I work for CSIRO Astronomy and Space Science. Now, unlike Ed's things, we don't run the optical telescopes. We actually run a series of radio telescopes. So CSIRO is the largest sort of government science research organisation in Australia. It does all sorts of different things. And I work in the Astronomy and Space Science Division. And we've got an amazing array of facilities. So hopefully you can see now on the screen. You should be able to see, I'm sharing the screen, if that's come up okay. You can see that we have two major facilities, the Australia Telescope National Facility here and the Canberra Deep Space Communication Complex. So ATNF, as it's known, is basically the radio telescopes, and the Canberra Deep Space Communication Complex is one of the 3 NASA Deep Space Network stations around the world, and CSIRO runs that for NASA, and that's involved in spacecraft tracking and communication for anything beyond Earth orbit. So the stunning images you see from the Mars Curiosity rover, more likely coming back through our station down at Tipimbilla, the CDSCC. So here you can see the major facilities that we've got. We've got an amazing array of instruments. Here we've got the Parkes 64-metre antenna, commonly called the Dish, and some of you may have seen that wonderful film, The Dish. And we've got the Australia Telescope Compact Array, which is 6 22-metre antennas. And we've got a 3-kilometre long east-west and a 250-metre long north-south rail tracks, and so we can relocate these antennas along that to give different spacings. We've got another 22-metre dish at Mopra, which is actually just down the hill from the Los Cumbres observatories and the other telescopes up at Siding Spring near Coonabarabran. ASCAP, I'll show you another picture about them later. This is our brand new telescope that's currently being commissioned, and that's in outback Western Australia. And then down at the Canberra Deep Space Communication Complex, we've got a 70-metre antenna, two 34-metre antennas, and we're currently building two new 34-metre antennas. So you can actually see, we've got webcam where you can see the construction of the 34-metre antennas as they're going along. So if you tally that up, we've got an amazing array of instruments. And in fact, they're now scattered around Australia. So I'm actually sitting in our headquarters here in Sydney. Most of our current telescopes are here in New South Wales or down in the ACT, Tidbinbilla. And if you have a look here, we've got telescope at Narrabri, Mopra and Parkes, and we can link these together in real time with high-speed fibre optic links to simulate a much larger telescope called the Australia Telescope. So, in fact, the telescope at Narrabri is 25 years old this year. It's had major upgrades since, so it's still state-of-the-art. And we've got the big open day coming up there on the 1st of September. So if anybody feels like coming up to Narrabri for that, we'd love to see you. And Parkes is our large 64-metre dish. And in fact, I'm heading out there later this week. We've got a program I run called Pulse at Parkes, where we have high school students get time to use the Parkes telescope in real time, normally via the internet. And in fact, our first overseas session we ever did was where Ed works over in Cardiff. So we had Welsh high school students sitting in Wales controlling the telescope at Parkes and studying pulsars. And then we've got the Murchison Radio Astronomy Observatory.
It was lots of fun, actually. I remember it well. Fond memories.
It was great fun. So we were actually doing a thing called pulsar timing. So we're doing accurate timing of the pulsars, which was pretty neat because if you're a Doctor Who fan, you'd know that Cardiff is on top of a time rift, which was a lot of fun. But the Murchison Radio Astronomy Observatory over here in Western Australia is where there's two major telescopes there at the moment. There's the ASCAP, I'll show you in a minute, and another low-frequency telescope called the Murchison Wide Field Array. And that's also going to be home for parts of the square kilometre array that's going to be the sort of next generation mega science project in radio astronomy. 11 nations involved, and there's going to be SKA, parts of the SKA in Australia, and there's going to be parts in South Africa. And as part of that, we've now got a new facility, the support facility down here in Geraldton, which is on the coast, whereas in at Bellardi Station in the outback, it's about a 4-hour drive. And then there's also a new high-performance computing centre called the Pawsey Centre down here in Perth that's due to open soon, and that will have supercomputers in there for handling the data coming from here in Western Australia. So just to give you an idea, this is what it looks like out in Western Australia at the out on Bellardi Station, the MRO. This is what ASCAP looks like. So this has 36 12-metre antennas with a new type of sensor called a phased array feed. And so this is the first radio telescope that's designed from the outset to incorporate these new phased array feeds. So it's very exciting. So ASCAP is designed to be a survey telescope, so it can see a large part of the sky at once, effectively an area about the size of the Southern Cross or crux, and so it's going to be able to survey the entire sky. And because we've got 36 12-metre antennas, we can go very deep, so we're going to be able to see things that we've never seen before. So it's a very exciting time for radio astronomy here in Australia. So how are we going there, Ed?
So I have something that I will share with you.
Okay, I will get out of screen share. There we go. So back to you. You should be able to grab your screen now.
Yep.
Oh, wow.
So this is a room. I think it's turned out rather well. You can see that there's a lot of this dark cosmic dust that I was talking about. You can really see this big red hydrogen region here in the middle is what most of the stars have been formed out of. But it's glowing beautifully with the illumination from the stars in that cluster. I always feel very lucky that I'm an astronomer because I have friends who are physicists and colleagues who are physicists, and they don't have beautiful images like this. So I can say, well, this is work, you know. And I've got a colleague who studies. He looks for supernovae, and supernovae almost always appear in external galaxies. And galaxies are some of the most beautiful things in the night sky. So he gets to look at these beautiful things all day, every day, and it's just, you know, a fantastic job to be in.
So Ed,
so
with the
I
image
just wanted to
we've got
share
there,
that quite quickly with you.
so
Sorry?
one of the things we've got there, if you look at the image, it's very obvious. You've got this wonderful sort of red nebulosity down the bottom right, which, as you've already said, is the hydrogen. Do you want to explain why we've got this, what looks like little blue wispy stuff up the top?
Here.
Yeah, the blue nebulosity.
Yeah, so I suspect that is still hydrogen gas, but it's fluorescent. It's glowing in a less. So there are two major hydrogen colors. The red one, as I said, but there's also a blue one, which is hydrogen beta, which is like there's hydrogen which has less energy that's being pumped into it by stars. And it's, I suspect it's that's glowing in this slightly blue color. It also could be a little bit of oxygen. So oxygen has a signature which is green, so we might be seeing a little bit of this bluey green color from oxygen there in this stellar nursery. So I'm just seeing where we are with our final. So we've got our third image of the galaxy. And once we've got that, I will. Actually, I will. I think I have to stop screen sharing. I can't swap over.
No. So actually, Ed was showing his prejudice a few minutes ago when he said that these galaxies are the most wonderful objects in the night sky. Of course, this is the coming from an optical astronomy perspective. They observe at night, whereas we run radio telescopes and we can observe day and night because we're not affected by daylight for most of our observations. So our telescopes actually work 24 hours a day, and in fact downstairs from my office here we've got our new Science Operations Centre where all of our telescopes can be controlled remotely from here in our Sydney office, and there's normally somebody sitting down there any time of the day or night using one or more of the telescopes.
So we're ready to have a look at. So there we go. That's our galaxy that we've been waiting for. So that's the NGC 253. So it's what we call a spiral galaxy. It looks a bit like the branch of a tree or a cigar at the moment. But if you imagine, it's remember I said that the Milky Way galaxy, the galaxy that that our solar system is like two fried eggs back to back. If you imagine looking at them from on top, you see the bulge, dense part in the middle, which is the delicious runny yolk, and you've got the arms, which are the whites around the outside. So if you imagine rotating that so that you see it almost edge on, that's what this galaxy is here. So let me see if I've got the. So these are other filter observations of the same thing. So we've got, this was our final one, which was, let me remind myself, a blue filter observation. And this was, in fact, I can probably look. So this is what's called the header file. This is all the interesting and a little bit tedious information about the observation. And if I can find, we've got. This was the red filter, and we also did a blue one as well. So I think I will go and slew the telescope off somewhere else and make a color image, and then we can talk about this beautiful galaxy in more detail. And if I get a chance, I'll pop them up onto the website so everyone can have a look at them in more detail. So what, do we have any requests on the chat window for what to look at? No, I don't think we do. So what have we looked at so far? We've looked at 47 Tucanae.
Yeah, I'm just wondering if we can get the one in Fornax, because that's a lovely barred spiral.
Yeah, give me a...
Hang on, I'm just trying to find where it was on my little list here. It's 3 hours, or is that's not... hang on.
Let's see. What's the designation?
NGC 1365.
No, that's too low, unfortunately.
Too low now. Oh dear. Okay.
We can certainly grab a another globular cluster, or there's M8 as well.
Yeah, let's go for
Messier
an 8.
8.
Let's go for that.
So we're going to slew off to M8, and while it's doing that, I think I will download all the data and try and make us a nice color image like we had of the Trifid.
So M8's another well-known object. Should look pretty stunning. Its common name is the Lagoon Cluster, or NGC 6523, and it's another cluster or another nebula in Sagittarius. Again, one of these stunning H2 regions, an emission nebula. Probably about 5,000 light years from Earth. But what we might be able to see in this one is, if we look closely, you might see that whilst you've got this wonderful sort of nebulosity, you'll see some sort of what look like these little dark holes in the nebula, and these are called the Bok globules. And basically, these are regions that are sort of collapsing quite cold relative to the surrounding area, and you're going to have new star formation eventually inside these.
Okay, so we've acquired the target, and I'm just going to grab an exposure of it. I'm going to do a B filter because that's what we were on previously. And I'll create a, while it's doing that, I'm going to do a nice image of our spiral galaxy. So let's. I also have, while that's happening, I have our final Eagle Nebula picture, which I'll share with you. If I can. There we go. Right. Right, here you go. You should be seeing the Eagle Nebula.
And that looks very much like an eagle to me. Look at that. You can see the wings and the head.
So this is what we observed a couple of years ago. This is, yeah, there you go. Look, there's the wing, there's his head. Yeah. So remember, all the dark bits that we see inside the nebula are dust, cosmic dust. And this is, remember, this is a red image, so hopefully you've hammered home by now that red is very often an indication of hydrogen gas. So actually, even this V shape at the top of the nebula, that is cosmic dust obscuring part of the nebula, and the stars that you can see are in the foreground. So that's a slightly confusing thing about astronomy, is you're never entirely sure whether you're looking in the foreground at something or in the background, and often, unless you've got a very special type of measurement called spectrum, you very often can't tell what it is. So we've successfully got one of our images from M8. It looks very nice. I won't show it to you just yet because I'll let you bask in the glory of the Eagle Nebula for a little bit longer. And I'll carry on doing observations of it for us so we can get a nice colour, because I think that M8 would be a nice one to have 3 colours of. So yeah, just looking a little bit more at this Eagle Nebula, so you might remember that we said from our other nebulae particularly the Trifid Nebula, that stars are being born. Well, in the case of the Eagle Nebula, you can see that there are bright bits on the head of this column here. So there's a very famous NASA image called the Pillars of Creation, which are these three pillars here. And NASA put them standing upright instead of like an eagle flying off. And they're called the Pillars of Creation because at the top of these dusty pillars, you have a glow, like there's something emerging out through this cocoon of dust. And actually, that's very true. That's what's exactly what's happening from this dust enshrouded area. Are little stars being born, and these stars are very hot and very bright, and that's why they're making the gas and the dust glow such a lot. And that's why it's called the Pillars of Creation, because there's a lot of creation of new stars and going on in these regions. We can't actually see the stars themselves because they've got this dust around them, but the dust's heating up and we're seeing the emergence of that light glowing through the dust. Let's see how our other observations are getting along. Okay, so we've got 2 down, 1 to go of our images of M8. So I'll just queue up the next one. Right, very nice, and just going to end this sequence off with a red observation. And if you have any requests of Southern Hemisphere objects, please let us know in the chat window, in the comments on the video. That would be really great. We'd really like to have some interaction with whoever's watching. So we're off on our final observation of this sequence. Right, I'll stop sharing my screen now. There we go, there's me again. Okay, we've got about 60 seconds left of that observation. So I'm going to download these 3 again and see if I can make something that looks nice out of those. So Rob, where do you think we should head off to next?
Well, I'm just checking the see if we've got any requests come through. Just
or any questions as well. That would be.
Yeah, I'm just checking. Waiting it to update. It's just taking a little second. Check back there. Yeah, can't see any yet. Hang on. Oop. Oh, that was silly. I just closed that window. I'll have to do that again. Just a. All right. So while we're waiting there, just wondering if Omega Centauri is not too low. Might be a little bit below the telescope limits at the moment, but if you can just check, that's NGC 5139.
Okay.
Just check if it's might be a bit low now.
Let's have a wee look. Yeah, that's going to be too low.
Yeah, all right. So my other option then again, what about NGC 1566? That's a face-on spiral in.
Oh, that would be very nice.
Yeah, try to show a different looking galaxy, but yeah, Just need to check.
I think that one might be okay. It's at the right ascension of 4, so. So might be a little bit low.
Okay. The other option is.
Well, let's give it a go. I'm still having a.
Okay.
That's a little bit low. It's rising, but it's a little bit low.
Okay. Well, let's try. Well, let's leave that a second. There's NGC 1300. That's about. So it's a barred spiral in Eridanus.
Yeah, that one's not going to wait for us. Rising about now, so it's not even above the horizon yet. Well, let's see how we're doing on this final observation. Okay, if I share my screen with you now, you can see this beautiful view of M8. My browser's being a little bit on the slow side, but hopefully you can see that now. So we've, can you see that? Is that clear up?
Yep, it's looking very impressive. Yeah, it's amazing the difference. You got this. You could almost see the the contours in the nebulosity. So it's
yeah.
And then down the bottom
so this
right.
Is the, yeah, this is the Lagoon Nebula, as we said previously. So we've got some really nice bits of dust in there, and it's really come across quite nicely. I'm going to make a 3-color image of that as well, so that you can really get a good sense of the different elements that are at play there. So that was just a little sneak peek at that, but I also have an image of the galaxy we were looking at earlier on, NGC 253, which you remember it was an edge-on spiral, I said before. So this one needs a little bit more processing because my automatic routine hasn't lined the stars up particularly well, but you get a good sense of the spiral structure now. You probably couldn't see that terribly well before, but so these remember everything. So in this lozenge shape here, everything that appears dark, like the dark filamentary things, that's dust. Galaxies have an awful lot of dust in them. They have massive spiral arms, which are almost entirely dusty things, and as they turn around in the galaxy, like the spokes in an enormous bicycle wheel or a cart wheel, they spontaneously start stars being formed as they run up against big clouds of gas and start them to collapse and form baby stars. So this thing is an enormous wheel, if you like, that's going around, and we're looking at the wheel almost edge on at the moment. So this very bright thing here is the center, and you can probably see just here, or if you can maybe see my crosshairs there, you can see that there's a bend in the spiral arm, and it gives you up here again in the northeast of the galaxy. Remember, as astronomers are strange beasts, we have north up and east on the left-hand side, which is, if you think about looking at a map of the Earth, you would normally have up north, but you'd have east, the the right-hand side. But if you imagine turning that map and lying on that map, looking out on the stars, your back flat on the ground, that's why you think the east is in the same place, but now you're looking the other way, so it's actually on your left-hand side instead of on your right. So I'm just following up a lead for our next project, unless you have one. Now there was we found a very nice little spiral, a face-on spiral, but that again was not visible for us.
So we've had a request, it looks like.
Oh, okay.
NGC 6744.
NGC 6744. Okay. Oh, that's a contender. Let's quickly. It's a spiral galaxy.
Yeah. Constellation of Parvo.
Parvo. I think this one is the one for us. So I don't wish to worry anybody, but I just lost my internet connection to the telescope. So I'm glad that I've still got the image of the galaxies up, so you can't see what's happening. So I'm going to go to Gallifrey for a little bit, and Rob's going to do a dance for you so that I can try and get the telescope back working.
This is the joys of technology, yes, anyway. It's probably having an afternoon tea break or something like that. So while we're there, has anybody got any other astronomy questions? We'll see if we can do our best to answer them. Just seeing if we're checking our window up. So, okay. No, nothing at the moment. All right, so, hang on, just checking if we've got one. Oh, no, not yet. Just wondering if people are there online. Love to know where you're from, where you're viewing us from. I think we've got somebody online who I'm guessing may be up early on a Sunday morning in Sydney. Hoping we've got some other folks around the world following us, not too late in the UK or in Europe. So we've got a reasonable sort of time spread at the moment. So the one we're going to try and find once it's got the control back is it's a spiral galaxy. So we've already seen one, which is NGC 253, but it was sort of almost edge on. So best way to sort of picture a spiral galaxy, if you imagine taking a CD, and if you look sort of down on the CD, so you can see the hole in the middle, that's like looking top down on a spiral galaxy. But if you turn the CD to the side and you see this very thin disk, that's what an edge-on spiral looks like. And of course, you know, these galaxies are just randomly aligned relative to us in space, so we can see the whole sort of variation. So if you've got one that's face on, you can see all the spiral arms and all their splendor. And if you've got it sort of flipped on its side, like NGC 253 almost was. Another classic one is the Sombrero Galaxy. Those are sort of the edge-on. The one we're going to look at now, hope, is a nice face-on one, so we should be able to see some of the spiral structure in the arms and the nucleus, or the bright central region of the galaxy. And when we see these the nuclei, or the central part of these galaxies, we think these days pretty much most of these spiral galaxies and elliptical galaxies have the supermassive black holes embedded in them. Indeed, our own Milky Way has a supermassive black hole at the centre. It's not something to panic about, because contrary to popular conceptions, these black holes aren't sitting there sucking up everything. We're perfectly safe going around the supermassive black hole at the centre of our galaxy. But occasionally things do get too close, and then they can get disrupted and fall in. And in fact, this is happening soon with our galaxy. There's a cloud of gas near the centre of our galaxy, near this supermassive black hole. And so predictions are that this thing should sort of be tidally disrupted and fall in on the black hole over coming months, or later this year, early next year. So a lot of astronomers at the moment are using telescopes around the world to monitor the central region of our galaxy to see when these interesting things, when this happens, because it'll be first time we've been able to sort of predict and observe one of these events relatively nearby, relative being the centre of our galaxy, which is of the order of about 30,000 light years away. Interestingly, of course, if you look at the centre of our galaxy in Sagittarius optically, you don't see anything particularly special. It doesn't look particularly bright, or you can't see an obvious central region. And that's because, as Edward's mentioned several times already today, there's a lot of dust out there in space. And in fact, we're lying on the plane of our galaxy, in the disk of the galaxy. And in that, you've got the dust and gas. And so if we look towards the central region, there's a lot of dust and gas between us and the very centre of our galaxy, and that obscures the optical light. However, we can observe it using infrared telescopes and using radio telescopes. And in fact, the actual centre of our galaxy was discovered by CSIRO radio astronomers in the early 50s using a telescope they dug in their lunch hour, believe it or not, out in the eastern suburbs of Sydney at Dover Heights, the so-called hole-in-the-ground antenna. And then from that established what we now call the galactic coordinate system that's used by astronomers all around. We have a question coming in. Okay, so from somebody in Houston asking, do the curves in... Hang on, I'll have to go to something here to get the question. Let's just have a look. All right. Okay, do the curves in spiral arms indicate a comparable rate of speed? So I'm just trying to... Do the curves in the spiral arms indicate... Just trying to get a grip on the question here. So basically, spiral arms in the galaxy, obviously we're in sort of, the galactic suburbs, and they, the spiral arms are spiraling around the center of the galaxy. I'm trying to, if we could just get a clarification on what we're actually asking with that question. One of the things about galaxies is we now know that by studying the rate of rotation of the galaxy, if we add up all the visible mass that we could see in the galaxy, the galaxies are rotating faster than they should for the amount of visible mass that we can see. And by that, we don't just mean stars, but we can also measure it using things like radio telescopes, weigh up the amount of cold gas and so on. And so galaxies seem, the rotation curve of galaxy indicates that there must be a lot more matter in the galaxy than we can currently detect. And so this is one of the key bits of evidence for so-called dark matter. So dark matter is matter that doesn't interact via light, but it has mass. And so one of the big questions in physics and astronomy at the moment is trying to figure out what dark matter is. Now, one of the things, well, there's been a lot of research going on in this, and in fact, to date, we've been able to rule out various candidates for what dark matter is, so we now know more about what dark matter isn't, if that makes sense, but we're still trying to pin down exactly what dark matter is. It's a very lively field of research. We think, dark matter plays a major role in the evolution of the universe and the interactions in the universe. So how are we going there, Ed? Have we got any progress?
We're back again. So one of the occupational hazards with running a remote telescope observatory is that we have telescopes at the end of sometimes quite flaky internet connections. So South Africa doesn't have the most reliable of internet connections to us over here in the US, and that's where our control system, our operations center is based. But we're back up again, and we've slewed to our target for, thank you very much, from lookup tonight, our target of NGC 6744. So I'm pretty sure that we are now tracking on the target. Yes, we are. I'm going to, now I think what we've got is a beautiful spiral galaxy, so I'm I'm going to set up this exposure for us to do another set of 3-color images. Now, I think we might be running up to the end of our time by the time we finish these 3. So make sure that if you are listening and we haven't done your favorite object, we go off and slew somewhere else if you would like us to, instead of doing a 3-color of this. So off we go, and I'm very pleased that we got back. We came back to life again.
So we've had a clarification of our question, Ed. They want to know what the curvature of spiral arms. What does the curvature of spiral arms mean in comparison to other spiral galaxies?
Because some of them are quite tight spirals, and some of them are quite wide spirals. So it could be. This is a very good question, because I don't think the answer to this is is known. One theory is that if you imagine that spiral galaxies are in evolutionary sequence, that you have some of them have tight spirals, so the spiral arms are almost joined up, and they're very, very tight circles, almost like concentric circles. And with time, as they spin out, these arms get wider and wider. That's one idea. Another idea is that galaxies undergo interactions with other galaxies continuously throughout their life, because gravity is everywhere, and gravity could, the gravity of something that passes relatively close can stop a galaxy having tight spirals, and it can pull out the spirals into something a lot more, a lot wider. So, and that's my favorite, is that it gives an indication of what that galaxy's been through, the trauma that it's been through over its life. How many other galaxies have interacted with it, have pulled on the arms and wrenched them out, a little bit like somebody pulling out the spokes on a bike wheel. It's a very destructive thing. So I think that's probably as sort of.
Hopefully we might be able to see this even with this image here, because even though it's a face-on spiral, hopefully we'll be able to detect that it's not sort of like perfectly circular, slightly elongated. So
yeah,
we'll just wait and see what the image.
Yeah.
So
the image is going to be popping up very soon. So I will share my screen now, and we can have a look at it.
Okay, there we go.
I'm just going to start the next exposure going, and here it is, nice and large. So you can see here what I was talking about with the arms being quite wide, and there's, you can see how many arms are on this one. So you've got one clear one there, another clear one down here. This thing here looks like a really diffuse arm. And there might be another one up there. So I reckon that's 4 spiral arms on that one. And if you're interested, there's something called the Hubble tuning fork diagram, which is what astronomers often use to categorize different types of galaxy. And from elliptical galaxies, which look very much like globular clusters with many, many more stars. They have hundreds of millions of stars instead of hundreds of thousands of stars, all the way to beautiful spiral galaxies like this one here.
So the other thing you can see there, Ed, we may just be able to make it out. If you have a look, sort of the top right quadrant, you can see that really bright star. And then up in the very top right corner of the image, you can see what looks like a nebulosity. I think that's probably the companion galaxy to it. So there's a distorted companion. So you can see it's sort of stretched out. So it's been sort of gravitationally disrupted by the large spiral galaxy.
Yeah, and that's a great example of what I was talking about earlier with the with where the shape of these galaxies comes from.
Yeah, so it would be similar to if you were able to zoom out into intergalactic space and look down on our Milky Way, which is would look fairly similar, and you'd see these sort of disruptions from the large and small Magellanic Clouds too.
Yeah, exactly. Yeah. So I'm just downloading some of these data files, and I'll use that for making a nice image for us of our previous galaxy. If I can remember what it was called. So let's see how we're getting on with that. So we're reading out of that one now. So that's our third. So we're just going to move on to our third. Here we go. Here's our.
This is one of the joys.
Here.
This is one of the joys of having a 1 meter telescope. This is so quick to do.
Yeah, that's right. So if you were using an amateur telescope to do this, this would be several hours worth of integration, probably, and of exposure time. And I've just, in a rather cavalier way, just done it in 2 minutes there. So, okay, we've configured that, and I'm just going to start the last. So, thank you very much to Look Up Tonight, who has given us a fantastic suggestion. Do we know where Look Up Tonight's joining us from?
No, they haven't told us yet. While we're actually in this part of the sky, there's another nice little globular we could probably go and look at, also in Parvo, called NGC 6752. Might be worth a quick look.
Yeah. 6752. Okay.
Should be pretty
right, well,
close.
I'm going to stop sharing the screen and put you back to that so that I can do some image magic stuff with the galaxies as they come off. Produce a nice color image.
Okay, so we've actually just had a question come through from 88 Skywatcher and wants us to know if we could see the new supernova in M74. But I'm thinking M74. Just a second. Just have a look. Okay. So Pisces, just got to check if Pisces is visible at the moment. So M74, I don't know if that's off the top of my head. Are we going to be able to see that at the moment, Ed?
No, I'm.
No, I think it's probably. Is it below? Below our horizon.
On that one.
Yeah. Yeah. So very sorry about that.
Just do a quick check. It would be nice to get.
Yeah,
We've had a user request, audience request. Yeah, that's. If we'd been doing this later on, in about 2 hours' time, that would have been visible to us. It's a bit of a shame. And I think we're just reading out and getting our final image of this color sequence. So I will let you have a look at this one. This one's quite different to the other image that we got with that. So there you go. That is the final image in that sequence, which was a B. It's a blue-colored filter. So we've got the blue, the green, and the red. And so we've got different scaling functions there, but you can see that it appears to get brighter between the red, the green, and the blue images there. So I'm going to download those and make a nice color image for us to have. And so I'm going to put all of these images onto Google+, but I'll also put them onto the LCOGT.net/Southern Cross 2013 page, so that you can download them and have a look at what we were doing this time around. So, any further suggestions? We've had a request.
Oh, okay.
Yeah, okay. I had a request for the Tinkerbell triplet.
The Tinkerbell triplet?
Yeah. Just looking that up. So that's that was provided by the.
Sorry, we lost you there, Ed. What was that?
Oh, it was the suggestion was provided by the QI-ELF. So I reckon this one is visible if we want to give this a go. I'm quite intrigued about what this actually is.
Well, I'm assuming an elf would know about Tinkerbell, so there you go.
Yeah, exactly.
Okay.
Wow, this looks quite spectacular. The colliding. So this fits in with the question that we had about spiral arms, because it's actually a highly interacting system of galaxies.
So we've got two big spirals and an irregular.
Yeah. It's also called the bird.
Looks a bit like a hummingbird almost, or
yeah, that's right. You can definitely see how that's. Trying to look at what its catalogue name is.
Well, it's got an ESO, so ESO 593. So yes, there's a.
Yeah. Doesn't have NGC. Yeah, it doesn't have an NGC.
No, it's an ESO Galaxy ESO 593, and it's an Iris Iris 1911.5 minus 2124. So, all right, we got an image there, or.
No, I've got. Is it 593 or is it 755? I've got an idea of 755 for it.
Okay. Oh, I've got a 755 as well. So yeah, okay, because it's all right. Yep.
Yeah, that's right. Okay, but that might be. It's Interacting Galaxies catalogue. Okay, well, this looks like it could be a good one. Okay, I'm just going to have to.
Well, the IG008 is that?
Yeah, the ESO 755 is the image name.
Yeah. So the galaxy is ESO 593-IG008.
Yeah.
So it's about 650 million light years away.
Yeah. Okay. I'm going to go to Gallifrey and do some maths on converting the coordinates. So I'll leave Rob to talk to you about.
All right. So look, this is this has been our, well, Edward and I, this is our first run at one of these. We've been enjoying it so far. I think we're keen to do more. So I guess if you're listening or following us out there, if you've got suggestions of what you want to see next time, next time we'll certainly make sure we schedule it so we could show you some of the other iconic southern sky objects like NGC 5128 and the like. But if you've got particular favourites, if you send them through, we'll see what we can schedule in and fit in for another session. So I guess we've got some flexibility with telescopes in that we've got them in South Africa, we've got them in Australia, and we've got them in Chile, so we could find a time to go with some of the objects that you want to see.
Yeah, absolutely. It's been quite a nice experiment. This I've enjoyed it a lot. It's a very different way of doing some astronomy for me, anyway. Right, I'm trying to acquire this source. So let me see if we've got there.
Okay, so we're looking at the time here. This is probably likely to be our last source for the session.
Yeah.
It sounds like it should be a really interesting one to end up with. You know, what we're hoping we'll see here is what we call interacting galaxies. So Edward already mentioned the fact that galaxies sort of interact, but when we say interact, they don't just sort of interact at a distance. Galaxies can and do slam into each other. So we know, for instance, that our galaxy and the Andromeda galaxy are going to collide in billions of years' time. But we actually see this all over the place. So I guess the classic example of interacting galaxies, the colloquial name is the antenna galaxy, where you've had these galaxies pass through each other, and then the tidal disruption, you get these amazing sort of plumes of stars coming off. So they're fascinating objects for astronomers to study because there's so much you can learn from them, and you can, interacting galaxies can trigger new bouts of star formation. You can throw stars out of the overall galaxy and the like. So wonderful objects, and we don't just study them with the optical telescopes. Of course, we study them a lot with our radio telescopes too, to try and figure out what happens, particularly to the gas that comprises a large component of most galaxies.
Right. So I think we've acquired that target. I'm going to just try and sneak in a red image, maybe all that we've got time for. With our remaining 5 minutes.
So this is likely to...
I might go with a blue. I think blue might be better.
All right.
Sorry to interrupt you there, Rob.
So do you want to tell us what sort of exposure time you're looking at?
Yeah, I'm going to go for a 120-second exposure of this, and we'll see how it goes. We might have time to play around with the exposure times there. That's what I've been. My rule of thumb has been: if it's a galaxy, do 120, and if it's a nebula, do 90. And it's very much playing it by ear at the moment. Okay. Just having a look at my status on everything else. Everything else looks good. Okay, well, fingers crossed. So while I have 60 seconds, I might just show you some pictures of Las Cumbres Observatory telescopes, just so that you can get a good handle on what we've been using today. Just like Rob did earlier. So if you just bear with me. Okay, so you can see, hopefully, that is a picture of one of our 1 meter telescopes. There's the telescope, and there's the enclosure. And there's our nice big logo, and that's me. So we have a 1 meter enclosure in our parking lot, or car park, as I would say, directly, probably about 50 meters away from where I'm sitting right now. This is exactly what it looks like. A 1 meter telescope in a 1 meter dome, and right next to it there's a little, what looks like a tiny kit car garage, which has some little telescopes in it, called 0.4 meter telescopes. The telescopes we've been using today are here in South Africa, and this is, in the center of this picture, is my friend Abby. I work with Abby. He lives in South Africa and runs educational projects as well as doing scientific research with people in Cape Town and people in the local area in Sutherland, where this where the observatory is based. So here he is doing a talk around these 3 telescopes, and we're actually using telescope Dome A, which I think is the one at the back there. But I'm not quite sure on the orientation of this picture. So all 3 of these have 1 meter telescopes inside them like this. And the reason that we have these in the car park is because we built the telescopes, we designed and built telescopes, we designed and built the software that operates them. So we wanted to have a place that we could test out a real-life installation of the telescope with our software before we sent them off to South Africa. So here's a picture just to show you that although we put these telescopes in fantastic places in the world, sometimes the weather conspires against us. And this is a picture of Sutherland during Christmas. I think we've sort of spun around now, so I think this one here is Dome A. So you can see that it's not really much good to try and do observing when there's lots of snow on the ground. But most of the year we've got really good quality skies, and that's why we put telescopes in remote locations. Like, you've heard of Cape Town, but you've probably never heard of Sutherland, because Sutherland's a small town that is, I think, probably about a 7-hour drive northeast of Cape Town. So it's very well away from all the lights, all the noise and all the action that happens in Cape Town, and that's very good for doing astronomy. But those aren't the only telescopes that we have. We have telescopes in Hawaii, we have them in Siding Spring, as Rob was saying. We have 2 meter telescopes, we have 1 meter telescopes, and I'm hoping soon that we'll have some 40 centimeter telescopes that will be able to be put in Hawaii, in Australia, some in Chile, and then hopefully we'll be able to roll some more out to these other locations like McDonald Observatory in Texas. And you can have a look at that website address there at the bottom of the page, LCOGT.net, to find out more about those telescopes. So I just wanted to give you a little glimpse of some of the telescopes that we have in our onslaught. Here's a picture of one of the 40 centimeter telescopes that we were commissioning inside the enclosure of the 2 meter telescope. Now remember, this 2 meter telescope is the size of a double-decker bus. So although it looks quite small there, the doorway that you can see at the bottom of the picture is 6 feet tall. It's probably 6.5 feet tall. So what's that? I don't know what that is in centimeters. That's probably 200 centimeters. So this is the size of a double-decker bus. This is the size of R2-D2, if that's a useful measure for the size of astronomical telescopes. And this enclosure is very different to our 1 meter enclosure because the whole telescope enclosure falls away, leaving the telescopes that are inside it bare to the elements. The reason for doing that is so that you can move the telescope around really, really quickly. Because as we've seen tonight, so a lot of traditional telescopes would be used by maybe 1 or 2 astronomers in one night, and they would look at maybe a handful of different targets. But as we've been doing tonight, we've been moving the telescope around lots of different directions. So having the enclosure out of the way allows you to slew all over the place and see things in a very short time scale of each other, because we've got perhaps hundreds of observers using our robotic schedule every night. So as I said before, what I've been doing is a little bit of a cheat, because I'm using our engineering control interface. And if any of you wanted to use our telescopes, you wouldn't use this, because it's very inefficient for us to sit here and push buttons. It's much more efficient to say in advance, I want to look at these things, put them into the queue, and the telescope scheduler will decide which telescope. So it might be the one in Hawaii, it might be the one in Australia, or it might be this one in Cape Town, in Sutherland in South Africa, that gets picked. But a computer decides that, and we don't have the thing where Rob and I are going, is that visible to us? Oh, no, it's not visible, and all that dead time. So anyway, moving on. So these three look very similar to the ones I showed you in Sutherland, but they're actually in Cerro Tololo in Chile, and there's three of them again. This is long exposure with the dome whizzing around, with the slit that the telescope usually peers out through, whizzing around, and so you can see the inside of the telescope illuminated by some LEDs. And finally, this is our plan for sending out what we'll be sending out, sending our 40-centimeter telescopes in. It's like a mini version of the 2-meter telescopes enclosure, and we call this an Agawan enclosure, which means it's Chumash, which is a local native group of people from the California area, and it means to keep dry. So there's a little picture of two 40-centimeter telescopes in an enclosure. That's from our parking lot. So I can see that our observations have finished. I sneaked another one in there, and I'm sorry to tell you that it doesn't look as impressive as we were hoping. So let me share with you the image. Now I suspect it's because the Tinkerbell triplet was a very, very faint object that had been observed by the European Southern Observatory on their VLT, and so this is our image here where you can't see anything. So I suspect the galaxies were very faint and we just didn't observe them for long enough.
So I mean,
but we're out of time now, unfortunately. So we can't really look at these again. I sneaked another one in while I was talking.
So when it mentions the VLT, that actually stands for the Very Large Telescope. So we've been using a 1-meter telescope. The VLT is actually an 8-meter class telescope. So that's a seriously large. I think it is actually there just in the centre. If you sort of just slightly off the centre, you can see something that's slightly elongated that matches. I think that's it. Yeah, but it's very, very plain. But if you go and have a look through Google or something and pull up the Tinkerbell triplet, you'll see the image that was taken with the VLT. But you know, that's an 8-meter telescope, and I guess they were observing for a long time to get that image. So
yeah,
no surprise. But we can still see. You know, I think we've actually got it there, just towards the centre of that first frame. So that's not too bad.
Yeah, I'm just zoomed in to see if we can just give you guys a glimpse of what it would be like. But yeah, I think you're right, Rob.
Yeah.
I think it was.
Yeah, yeah. So I think we had it there in that original image, but yeah, not going to look quite as stunning. But
yeah,
look,
that's right.
Anyway, it's been fun trying to find those sort of things, and thank you very much for joining. I've had it pretty easy here. Edward's been the one having to drive an image process. I've been just sitting in my office making the odd comment, but it's been a lot of fun from my point of view, and I think
it's been a lot of fun from my point of view as well. So I hope you guys carry on giving us feedback, giving us some comments on the YouTube channel about what you thought about today's Big Dipper to Southern Cross with the Southern Cross element. And hopefully we'll be able to do this again and give you a true tour of the Southern Hemisphere skies.
It's been a great initiative from Astronomers Without Borders. So
yeah,
if you're not already following what they're doing, make sure you keep up with the huge range of activities they run around the world all the time. So it's been a lot of fun. So thanks to them and to LCO.
Yeah, and thank you to CSIRO for Rob's time.
That's a pleasure. Anyway, I think that's all from us, so I'll sign off. Thanks very much, Edward.
Yeah, thank you very much, Rob.
And following the skies around with you sometime in the future.
Yeah. All right. Thanks very much.
Bye.
Bye.